Good morning. Okay, so today we are going to continue with review. So today we're really going to focus on significant figures. All right, remember we call these sig figs. You'll see them as significant digits also. All right, they're all the same thing. All right, so scientists, just as a refresh, scientists use sig figs to determine how precise a measurement is. All right, so whenever we are measuring, which is what we're going to be doing in our Round Things lab soon, all right, whenever you are measuring things, you always have to include all of the known digits. So everything that you know beyond a shadow of a doubt, plus one single unknown digit. Okay. All right, you have to go to that one unknown. All right, so if we have a ruler or a measuring tape, all right, and this is our measurement right here. All right, we would have to go to the last known, which would be 13 point, we could go either 13.3 or 13.2. Let's go to 13.2. Okay, if we look at it. All right, so I am seeing that it's like right before that 13.3, so we would say it would be 13.29. If you said that it was right on the 13.3, then your unknown digit that you would have to estimate would be a 0. All right, both of these are absolutely correct, and they are the correct number of sig figs. All right, what about this one? Okay, so we go to the last known. All right, I would say that the last known would be about 12.8. And then I'm seeing that it is between the 8 and the 9, so I would say about 12.85 for this one. So that 5 being the estimated digit. Okay, so all of this applies with all instruments. All right, last year we used it with our graduated cylinders. All right, but this year we're mainly going to be using the meter sticks, the rulers, the measuring tapes, but also balances. Okay, so one thing about a balance, if I ask you what is the correct measurement with the correct number of sig figs, it is going to be the actual number on the balance. So a balance actually has that unknown or estimated digit built into it. All right, so this is already the estimated digit. You do not have to add it to the end of it, and because this is the one that keeps constantly changing. All right, if you put something on a balance, it's that last digit that's going to be just constantly changing, and that's because it's the estimated digit. All right, so this is just a review. We have to figure out if we have been given a measurement or if we have been given a number, we have to figure out how many sig figs are in it. Okay, so these are a couple of rules that we have to remember. All right, so all non-zero digits, so this is any number besides 0, so numbers 1 through 9 are always, always, always going to be significant. All right, so in 274, that is going to have 3 sig figs. All right, all 3 of those are non-zero digits. In 25.632, all of those are non-zero digits, so each and every one of them would be significant. 8.987 is the exact same way. They are all non-zero numbers, so they are all significant. So we would have 4 sig figs. All right, so that one's going to be the easiest one. So now the only number that we haven't talked about is 0, and zeros have several different rules. All right, so there are actually 4 different rules for zeros themselves. All right, rule number 2. So these are zeros between significant digits. All right, is that between? Remember, we call these sandwiched zeros. All right, they are sandwiched between other significant digits. All right, these are always going to be significant. All right, so we have 504. That 0 is sandwiched between two other non-zero numbers, so it is significant. So we have 3. 60,002, all 3 of these are sandwiched, which makes them significant. So that gives us 5 sig figs. All right, this 0 is sandwiched between that 9 and 7, which makes it significant. So we have 4 sig figs for that one. All right, so that one's usually an easier rule too. All right, so that's our first rule for 0. Sandwiched zeros are always significant. All right, now this one we called trailing with a decimal. Trailing with a decimal is always significant. All right, so these are zeros that come at the end of a decimal. All right, so 32.0. All right, it's behind that decimal. It comes to the right. That is perfect. That is trailing with a decimal. All right, so that would be 3 sig figs. 19.000. This one is trailing with a decimal, which makes these two sandwiched. All right, that makes 5 sig figs. All right, so we have 1 sandwiched right here. We have 2 zeros sandwiched right here. And then we have a 0 that is trailing with a decimal. All of these zeros are significant. So that gives us 7 sig figs for this number. All right, now rule number 4. This is kind of like rule number 4 and rule number 5. We call these zeros placeholders. Okay, so placeholders are not significant. So there are 2 kinds of placeholder zeros. All right, we have leading zeros. These are zeros that come at the front of any number. All right, so they are at the front. They can be before the decimal or they can be after the decimal, but they come before any other number. All right, so those are leading zeros. They are not significant. We also have trailing zeros without a decimal. If they do not have a decimal, then they are not significant. All right, so if we look at this one, all right, so all of these come at the front. All of these are leading zeros, so they are not significant. So we only have 1 sig fig in this. Okay, whenever we are looking at scientific notation, we're only looking at the coefficient. So that 0 is sandwiched, so we have 3 sig figs. Okay, now this one can be kind of confusing for some. All right, that 1 is the only non-zero number, but this 0 is trailing with a decimal. Okay, so that makes it significant, which makes these 4 zeros sandwiched. So that means that we have 6 total sig figs. All right, this one, 150,000, you do not see a decimal. All right, so that does not make this one significant. So we only have 2 sig figs here. Same thing with 800. There's only 1 sig fig there. All right, there is no decimal to make those significant. All right, I do want to point out one other thing. So we talked about trailing with a decimal. So most people think that this has to be trailing with a decimal. It has to be to the right of it, but it does not. All right, so if we just had 300 with a decimal, that makes this one trailing with a decimal. So it comes at the end, which makes it trailing, and there is a decimal behind it. So that makes it significant. So there are 3 sig figs in that one. All right, and then for this one, we talked about this a lot last year. but it's going to come into play a lot more this year. So all of our constants that we use have an infinite number of sig figs, so we will never use those for our number of sig figs that we're trying to figure out with our answers. All right, so we'll have things like gravity. Acceleration due to gravity is always going to be negative 9.81 meters per second squared. We're never going to use that in our number of sig figs, all right, because that is a constant. All right, so the only time that we're ever going to use a number of sig figs is whenever it is given to us, whenever it's a given. All right, so just a little bit more practice. How many sig figs are in the following? All right, for number 1, we have 3 zeros up here. They are leading. Leading zeros are never significant. So that would give us 2 sig figs. All right, these 3 are sandwiched between the 1 and the 2, which makes them significant. This one is trailing with a decimal, so that gives us 6 sig figs. We have 2 non-zero digits here, and then 2 zeros that come at the end without a decimal. So those are trailing without a decimal. Those are not significant. So we have 2. And then for this one, remember scientific notation. We'll get into that a little bit more later. All right, but for this one, we only look at the coefficient. So we have a 0 at the end with a decimal. So it's trailing with a decimal, which makes it significant. So we have 3. So we have this 0 right here. It's trailing with a decimal. That makes it significant, which makes this 0 sandwiched between 2 other sig figs. So all 4 of those numbers are significant. So we have 4 sig figs. All right, we have a ton of zeros up front. These zeros are leading, which makes them not significant. So we only have 1 sig fig there. And then number 7 is easy peasy lemon squeezy. All 4 of those are non-zero digits. So we have 4 sig figs. Sorry, I don't know. I dropped the pen. That's not. Okay. All right, so now we have to remember our rules for rounding. Okay, so most of these are easy. We're not going to be changing a whole lot, but there is a little bit of difference between what we did last year in chemistry and what we do this year. All right, so whenever you figure out how many significant digits you need, then you cut it off, but you have to use rounding rules. All right, so if the digit to the right of the last sig fig is less than 5, that should be an N. Less than 5, so that's a 0 through 4. Do not round up. We keep it. We do not round up. We keep it the same. All right, so say you have this measurement and you want 3 sig figs. So you would cut it off after that 3rd sig fig, then look to the right. All right, it's a 2, which is less than 5, so we keep it the same. So we would have 43.8 as our answer for that. Okay, if it is greater than 5, I don't know why that should be, I don't know why I put that instead of than. All right, if it is greater than a 5, so this is a 6 through a 9, then you round up. You round up. Okay, so you have 234.87 and you want 4 sig figs. So that means that you would cut it off after the 4th sig fig, and it would be, so there's a 7, so that's greater than 5, so we round that 8 up. So we would have 234.9. Okay, so we dealt with 0 through 4 and then 6 through 9. So the one and only number that we have left is the number 5. Okay, so last year in chemistry, we talked, like we just added 5s into this rule. Like it was 5 to 9, you round up, but 5s are going to be different now. All right, so with 5s, a big red flag should be thrown up in your head. So if you see the last sig fig followed by a 5, then a big red flag should go up. Ding, 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 ding. I've got to look at the next number. Okay. So if that 5 that's behind that last sig fig is followed by a non-zero digit, you are going to round up. Okay, so let's take this for example, 78.657. You want 3 sig figs, so you cut it off after that 6. Well, there's a 5 right after that 6, so ding, 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 big red flag should go up. You have to look at the next number. So that next number is not 0, so we round that number up. All right, so we round our last sig fig up, so our answer would be 78.7. Okay, 78.7. Okay, now this one, still dealing with 5. If that 5 that's behind that last sig fig is followed by a 0, then you make it even. You make it even. Okay, so let's try this one. So we have 2.5350, and I want 3 sig figs. So I cut it off after that 3. Okay, I look behind it. There's a 5. Ding, 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 ding. I have to look at that next number. Okay, that next number is a 0, so I have to make it even. Now, I'm never going to go down to make it even, so this would not be 2.52 to make it even. It's going to be 2.54 to make it even. All right, you're always going to go up. All right, now for this one, we have 2.5250, and I want 3 sig figs. I cut it off after the 2. There's a 5 behind that, so ding, 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 ding. I have to look at that next number. It's a 0, so I have to make this even. Well, 2 is already even, so we keep it the same. We keep it the same. And for this one, for this rule, if 5 is not followed by anything, then we just assume it's followed by a 0, and we would make it even. All right, so let's try these. All right, for 200.99, I want 3 sig figs. I cut it off after that 0. There's a 9 behind it. I round up, so my number would end up being 201. All right, for 18.22, I want 2 sig figs. Cut it off after the 8. There's a 2 behind it, which is less than 5, so we keep it the same. So my answer would be 18. 135.50, I want 3 sig figs. All right, I cut it off after that first 5. There's a 5 behind it. Ding, 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 ding. I have to go to the next number. All right, it's followed by a 0, so I have to make this an even number. So remember, I go up to make it even, not down. So my answer would be 136. For this number, I want 1 sig fig. You have to remember that all of these are leading zeros, so none of those are significant. So 2 is our first significant digit. We cut it off after the 2. There's a 9 there, so we round up. So our answer would be 0.003. Also, notice that this one has a 0 in front of the decimal. I did not put a 0 in front of the decimal. So because that 0 is leading, it doesn't matter if it's there or not. So it does not affect the number itself or the number of sig figs. So you can keep it there or you don't have to write it. And then for the last one, 98.59, I want 2 sig figs, so I cut it off after that 8. There's a 5 behind there, so ding, 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 big red flag should fly up. I've got to look at the next number, and it's a 9. 9 is not 0, so what we have to do is we have to round up immediately. So my answer is going to be 99. Okay, so hopefully you know how to determine the number of sig figs in a measurement, but what we're going to be doing, not only are we going to be measuring things, we're actually going to be doing the math with these things. So we're going to be adding, subtracting, multiplying, and dividing. So we have to remember what we do whenever we have these calculations. All right, so if we have addition and subtraction, we look at the fewest number of decimal places, the fewest number of decimal places. So if we have this example, All right, so we have 20.4 plus 1.322 plus 83. That is going to give us an answer of 104.722. Remember, I always want you to write out your raw answer. I want to see your entire raw answer. All right, because I am just adding, I'm looking at decimal places. This one has 1 decimal place. This one has 3 decimal places. 83 has 0 decimal places. So we want the fewest number of decimal places. So 0 is our fewest number. So we want 0 decimal places. So we're going to cut it off at the decimal. Well, we still have to remember our rounding rules. There's a 7 behind that last sig fig. So what do we do to that? We round up. So 105 is our answer. All right, so let's try these. So I've already done these, so I'm just going to write out all of these raw answers for you. So we have 69.03956. This is going to be negative 476.33. This one's going to be 72.144. This one's going to be 58.4428. This one's going to be just 20. Okay, so now we have our raw answers. Remember, I always want you to write out your raw answers. All right, so now we have to figure out our number, our answer that has the correct number of sig figs. So because what is this doing? Because all of these are just addition and subtraction, then, am I still recording? Yes. Okay, praise God, hallelujah. All right, so because I am just adding and subtracting, I am just looking at numbers of decimal places. All right, so this one has 5, this one has 3. We definitely want to take that lowest number, which is 3. All right, so we cut it off after that third decimal place. There's a 5 behind it. So ding, 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 ding. We have to look at that next number. It is not a 0, so we have to round this up. So our final answer is 69.040. We still have to have those three decimal places. All right, so now we have 2 decimal places right here and no decimal places right here. So we definitely want to take that lower number, which is 0. So we cut it off at the decimal. There's a 3 behind our last sig fig, so we keep it the same. So our answer, our final answer would be negative 476. For this one, I have 2 decimal places right here and 3 decimal places right here. So I want the 2, not the 3. So I would cut it off after that second decimal place. There's a 4 behind it, so we would keep it the same. So 72.14 would be our final answer. For this one, we have 4 decimal places right here, 3 decimal places right here. So we want 3 in our final answer. So we cut it off after that third decimal place. There's an 8 behind it, so we have to round up. So our final answer would be 58.443. And then we have 2 decimal places right here, 2 decimal places right here. So we want 2 total decimal places. Well, we don't have any decimal places over here, so we have to create those 2 just by adding 2 zeros at the end. Okay? I hope this is okay so far, but most of the time we're not just going to be dealing with addition and subtraction. Most of the time we're going to have some sort of multiplication and division in there. And with multiplication and division, we are not looking at decimal places. We are looking at the total number of sig figs, and we want the least. We want the least or smallest number of sig figs. I did not mean decimal places right there. The least number of sig figs. All right, so if we multiply this out, we do get 171.45. That's our raw answer. Remember, I always want you to write out your raw answer. All right, so now we're looking at total number of sig figs, not just decimal places. So I have 4 right here and 3 in this number. Okay, so I want the least number of sig figs, so I want 3. So I cut it off after our third sig fig. The 4 is behind it, so we keep it the same. So my final answer would be 171. Okay. All right, now for this one. All right, I did already calculate these, so I'm going to go ahead and write out these raw answers. Give me just 1 second. Go ahead and copy these down as I write them. You can go back and check me if you need to. I would love that. If I got something wrong, please let me know. 6, 9, 7, 7, 8, 141.954. All right, this one is big. All right, so you see this addition and multiplication. We have to remember our order of operations for this. All right, so we have to do that multiplication before we do that addition to get the correct answer. If you don't, you will not get this same answer. And then this one. Okay. All right. So I do want you to solve this one to make sure that you get the same answer as I do, because a lot of you do get these kinds of things wrong. All right, so I do want you to work this one out to make sure you get the same answer that I do. All right, so with these, again, we are doing multiplication and division. So we just have multiplication here, so we're going to go with the least number of sig figs, not just looking at decimal places. So I have 5 total sig figs right here, 3 total sig figs right here, so I want 3. So I cut it off after that third sig fig. There's a 4 behind it, so I keep it the same. So with these, you have to remember, this is 10,948. If I just put 109, that is nothing like that first number, that original raw answer. All right, so I do have to remember to put 2 zeros to act as placeholders for this. All right, so it's going to be 10,900. All right, for number 2, we have 5 sig figs in both of those, so I want 5 total sig figs. All right, so there's a 7 behind our last sig fig, so that's going to round it up, so it's going to be 3.9170. For this one, I'm still multiplying. It's just in a different format. So I have 4 in this one and 3 in this one, so I want 3. I cut it off after that third sig fig. There's a 9 back there, so we round up. So my final answer would be 142. Now for this one and the last one, you see that we have both addition and multiplication. Here we have addition, subtraction, and division. Whenever you have addition and multiplication or division, or subtraction and multiplication and division, the multiplication and division rules trump the addition and subtraction rules. All right, so we're always going to be looking at least number of sig figs, not just decimal places. All right, so we have 3 sig figs right here, 3 sig figs right here, 2 sig figs right here. So we want 2. We cut it off after that second sig fig. There's a 4 behind it, so we keep it the same. But remember, this is not just 18. This was 184. So we have to add that 0 back there to act as a placeholder. And then last but not least, it's the same thing. We have addition, subtraction, and division. So we're going to use division rules. So we're looking at least number of sig figs. So we have 3 right here, 3 right here, 4, and 4. So we want 3 sig figs total. All right, so we cut it off after that third sig fig. There's a 5 behind it. So what do? We have to look behind that. That number is a non-zero number, so we round up immediately. All right, so 0.844 is our answer for that. All right, now this one's going to be our last one for this set of notes. All right, so this is kind of mixed, but we also have units in with these. All right, so we have 18.36 grams divided by 14.20 cubic centimeters. So that's going to give us a raw answer of 1.292958. Remember, we're dividing, so we want total number of sig figs or least number of sig figs. Both of these have 4. So we're going to cut it off after that 4th sig fig, which is going to give us 1.293, and our unit would be grams per cubic centimeter. All right, for number 2, we are subtracting, so we're looking at decimal places here. So our raw answer, whenever we subtract, would just be 82.2. All right, but because we are looking at decimal places, we have 2 here and 2 here. So we want to make sure our final answer has 2 decimal places as well. So we have to add that 0 to the end. So our final answer is 82.20 degrees Celsius. All right, with this one, our raw answer, whenever we divide it, is 59. So we're dividing, so I want the least number of sig figs total. So there are 4 right here, 2 right here, so we want 2. So our raw answer already has 2. So our raw answer is our final answer, but we have to remember to put miles per hour, our unit. All right, we're adding this time, so our raw answer should be 226. All right, so we are looking at number of decimal places because we are adding. So we want 1 decimal place. Well, we don't have any decimal places here, so we need to add 1. So our final answer would be 226.0 degrees Celsius. And then last but not least, we have 460 divided by 5, which does give us 92. All right, well, this is division, so we want least number of sig figs. So we have 2 right here. Remember, that's trailing without a decimal, so it's not significant. And this is 1, so I just want 1 sig fig. So there's a 2 behind there, so I keep it as 9. But 9 is not the same as 92. I have to remember to put that 0 in to act as a placeholder. And then I add my unit, which is meters per second. All right, I hope that this came easy for you. Hopefully we're just remembering all of our rules from last year in chemistry. If you have any questions, just let me know.